Hello. I'm Ryan.
I'm
Kitson. Yeah, so we're going to talk about Deno. We decided before this, there's a controversy over the pronunciation of this project. For some reason, I've always been calling it Deno, but there's Reno, and Deno is why it's a dinosaur logo. Anyway, we're going to talk about Deno. And before I ever give a talk on this thing, I always have to give a disclaimer because some people always freak out about this project because it's very. We're getting some feedback. Yeah, I mean this project's pretty similar to Node in many ways, and a lot of people kind of freak out about this, and they're like, "Oh God, do I have to rewrite everything now? What's going to happen?" And I just say, don't worry about it. Deno is under development and very new software, and Node is very stable software that's going to be around for a long time. So, no existential crises here. So yeah, Deno's a new command line runtime, and it's for executing JavaScript and TypeScript. And it's built on top of V8. And in some ways, it's kind of a framework around V8. And it has the TypeScript compiler built into it. I'll talk about that a little bit. And it's built in Rust, and it's built on top of a thing called Tokyo, which is kind of serves the same purpose as libuv, if any of you recognize that. I won't tell you what that is, though. So naturally, the question is why would you want to do this? Node is working, and why rewrite this? And I would just say that a lot of things have changed in JavaScript since 2009. Namely, the async-await stuff in promises is now standard in JavaScript, and JavaScript has a new module system, this ES module bit. And type arrays. Originally, when we designed Node, there was no concept of using binary data inside of JavaScript. And that led to some weird design issues. Well, these days we have type arrays, and that's very good. And of course, there's TypeScript now, which is a very nice addition to JavaScript. And yeah, Node has some problems, kind of the typical legacy system issues, getting a little crufty. That's not such a big deal. The two more important deals are kind of the package management situation is centralized in one location, which is not as webby as one would like it to be, right? JavaScript is very webby, and you would kind of want something more distributed. And the other issue is security, right? V8 itself is a secure sandbox, for all intents and purposes. And Node has poked a bunch of holes in that secure sandbox to do system stuff, to open sockets, to read files and whatnot. And so when you're running a Node program, you lose all sense of any sense of security, right? Those programs need to be trusted in order for you to run them securely. But we can do better. And I think in general, the reason for working on this is that I want a fun and productive dynamic language scripting environment. And I think dynamic languages are very useful and are worth the effort to try to get it working as good as possible. And I think that neither Node or Python or Ruby are really satisfactory. So let me just tell you a bit about how this system works. So Deno is a single executable, and it's always going to be a single executable. So we ship a single file, and yeah, it works on Mac and Linux and Windows. And yeah, we just kind of strive to keep it independent from system libraries, right? We don't dynamically link to OpenSSL and whatnot. And kind of a different aspect here is the secure execution by default. So when you run a program in Deno, and by the way, notice that there's a URL there. So first of all, you can run URLs. So in some ways, Deno is a bit like a web browser for scripts. But back to the secure execution. So when you run a program, you don't need to trust it because by default you have no access to the system. You can't open files, you can't open sockets. That would be interesting in of itself, but you are running this on your laptop, and so you would like to interact with the rest of the system in some ways. And we allow you to kind of opt into various permissions. So for example, if you want to read from the file system, you can do -- allow read equals temp. That would allow you to read from like the temp directory. Or -- allow write would allow you to write to the entire file system. Or you could do like -- allow net equals Google. That allows you only to open connections to google.com. Or environmental variables often contain some secret information, so we don't allow you to access environmental variables by default. Yeah. So another aspect where we're trying to be different is this browser compatibility thing. So Deno is something that is a server-side runtime, in that it's not running websites. So what does it mean to be browser compatible? There's a lot of APIs that don't necessarily overlap with the browser, right? If you're opening a socket or whatever. We have our own APIs for those sort of things, but they're in the situations where we do overlap with browser functionality, we try to use the browser APIs. And I've listed the global scope, or at least a partial listing of some global scope things on there. So you can see in there like set timeout, that's obvious. But we also have things like onload and unload. So we have these kind of browsery type events. Yeah, and kind of probably the most obvious change here is that you import from URLs in Deno. And this is kind of a replacement, or intended to be a replacement for the entire module system. So if you're requiring an NPM module, right? You require Express. I mean, implicitly, you can also think of this as a URL. It's just like the server npm.org is implicit in that. We're requiring you to be explicit about which server you get this from. And by doing this, it adds a bit more code to or makes your imports maybe a bit more verbose, but with the benefit of now it's completely distributed, right? You can serve up your code from any URL. And yeah, the module resolution scheme in Node is just very complicated. There's this Node modules bit, there's index.js. It's a very complicated algorithm that maybe you're not even that aware of if you've never dug into it, but it's very, very complicated and complicates a lot of systems, including TypeScript. And yeah, we're trying to be very simple-minded about this. So it's only URLs, only relative URLs or absolute URLs, and that's it. So this is kind of a browser-compatible module system. And oh yeah, I should say that you might be worried that you can't. What if you're on an airplane? What if you don't have access to the internet? It seems unreasonable to require internet access for fetching all of these resources. But I mean, it acts the same way as when you npm install something. Like you can, on the first run, or you can do Deno fetch, you can download and cache these dependencies. And the algorithm is that we never update that cache unless A, we're missing something in that cache, or B, you ask us to. So this scheme can work offline. And most importantly, it has TypeScript out of the box. So the TypeScript compiler is compiled into Deno. And we use this feature called V8 snapshots. Raise your hand if you know what V8 snapshots are. OK. V8 snapshots is a feature in V8 that allows V8 to start up very quickly. And they basically load your code up into memory, kind of serialize this memory into a file, and then can take that file. This is done at compile time. Take that file and use it to start up your scripts very fast. We do this with the TypeScript compiler itself and the other code built into Deno. So at our compile time, we load all of this stuff up into memory, serialize it into a file, and then bundle that into the Deno executable, which allows us to start up very fast. We don't have to recompile the TypeScript compiler every time we start up. And yeah, we're fairly opinionated about our TypeScript usage. And we treat TypeScript as a first-class language. So in particular, you can import URLs to TypeScript files. And I think this is, well, I think this is kind of a simplification in the mental model for users. But let me get to that in a minute. Well, Kitson will talk about the TypeScript definitions that we ship at runtime. But yeah, so anyway, TypeScript is kind of this first-class language. And of course, JavaScript is also a first-class language. And when you run JavaScript code, we kind of bypass the TypeScript compiler completely and just kind of route it directly into V8. And so the hope is that with this scripting setup, the scripting platform that we have, that you can kind of start prototyping code in JavaScript, and if that code doesn't get thrown away, maybe you start adding types to it. You realize this is kind of a production system, and later on maybe realize that some bits and parts of your program are executing very frequently, some hot bits of code, and maybe those need to be moved into Rust. So yeah, there's kind of this esoteric point that I want to make. It's that in Deno, we treat modules and files as the same concept, which is not exactly what you see in Node, right? In Node, you have bare URLs. But even if you're doing a relative URL, you leave out the file name extension. And if you're in TypeScript and you're making a relative import to another TypeScript file, it's not totally clear that the concept of a module and a file aren't necessarily the same thing when you're programming with Node. And in Deno, we're making this explicit. So like files are modules. And I think this simplifies the mental model for users. If we can always say that what is a module is a file. How do you reference it? You always give a relative URL or an absolute URL to it. Right, so Deno was written in Go originally, prototyped in Go, but now it's a very rusty project. It's a Rust. It's written almost completely in Rust, and so what we're trying to do with this is, rather than kind of shipping this monolithic executable like Deno.exe, which we do, but we kind of want to open this up a little bit and break up the system into various crates so that you can potentially different users might not need the entire executable, but might just need to execute a bit of JavaScript or execute a bit of TypeScript. Maybe you're inside of a web server and you want to execute a little bit of code. You can kind of opt into these various layers because we've broken this out into a collection of Rust crates. Yeah, I mean, in particular, the use case I'm interested in is like this Electron use case, right? There are Node apps that are essentially like shipping their own executable, or or their own runtime, right? You could think of it that way. And yeah, I think that if we set this up correctly and kind of integrate properly with the Rust build system, that we can address these use cases in a much more clean way. And yeah, I would suggest that if you're interested in this use case, that you check out this Deno TypeScript crate, which I've linked to, which allows you to compile TypeScript at your compile time and bundle it into a V8 snapshot so that you can start up fast. Oh, now it's your turn.
OK. Can I borrow the clicker? Yeah, OK. Then we don't have to get too close to each other.
Right. We're getting feedback. If that's why we're standing so far
apart. We're not allergic to each other. I wanted to talk a little bit about, because I heard about Deno about 18 months ago when it was sort of first being announced, and I was interested in that, and I wanted to talk a little bit about my history. So, let you know how old I am. The first language that I did was really well outside of BASIC was Turbo Pascal. I did that in high school. Obviously, Anders is older than that since that was a language that he was responsible for. But so at least I consider that an accomplishment. Obviously, I followed Anders on to Delphi, but then he left for Microsoft, and I decided that I'd get involved in PHP. I don't know why I did that. I still regret that to this day. But that led to me getting involved in Dojo, in JavaScript, and then I ended up being in a situation of being the project lead for Dojo 2, which we rewrote in TypeScript. And then that gave me a lot of exposure to TypeScript, and then I decided to move to Australia and as far away as I could from Dojo, I needed something else to occupy my time, and so that's where I started with Deno. But the real reason that I do contribute to Deno is because of him, my son, who was born about 15 months ago. And so I had all this time on my hands while I was taking time off when he was born, that I contacted Ryan and I said, hey, I've got all this time. I know a bit about TypeScript. And we were having some challenges, really getting the TypeScript compiler well integrated into Deno. So that's where that really led to that. So what does Deno look like from actual usage? So how would I start a static HTTP server in Deno? As Ryan was saying, it looks a lot like this. It's a URL, and of course we want to access the network, and we want to read files from the file system. So that's what we will do here. So actually, this is my code. This is actually just on GitHub, and I've got a VS Code plugin that allows me to do that. And so I've got my server in there. I'm actually importing a module here and importing a set of modules here from a framework that's similar to Express. Pronto, allow, read, and allow net Okay. And so what's happening is Deno's going off. It's pulled the first module off of the gist on GitHub. It's done an analysis of that. It's realized there's other modules to pull off. It pulls off those modules, does analysis of that, and sends that all off to the TypeScript compiler and gets that back and loads that into V8. V8 will then do another analysis of the actual JavaScript modules that are dependent upon and generate the runtime engine. And so here we've got a little bit of a web server, and I forgot this bit. Oh, I didn't. Let's see, local host. And there is my little static web server. And you can see there I've gotten back the hits on that, and that's all there. As Ryan was saying earlier, though, we really wanted Deno to be a full sort of development environment. So one of the things that you might want to do is actually understand the information about your program. Deno Pronto. And so this has essentially given me a dependency tree of all the modules that were loaded in there. From a comparative perspective, this is 70 modules, 0 install. If you were to do this in Express, in TypeScript, it would be 72 packages. It would be 48 megs on disk. So you're getting the same functionality, and you didn't have to touch a package JSON. You didn't have to touch anything. You express all of your dependencies as code, and that's the way you manage dependencies in there. And Deno does the rest of sorting that out.
It's worth noting that this Deno info that he just ran also works on ES modules. So if there's just some random ES module on the web that it has nothing to do with Deno whatsoever, because we use the same module system, you can use this we're hoping this tooling will expand beyond just Deno itself, but be useful to browser programmers who have nothing to do with this.
And that's exactly it. And so it's that full tool set. So we've got Deno info, we've got Deno install. What was the good one with Deno land cat.js?
Standard HTTP or standard examples / catj.ts.
Oops.
And you have to give it executable name at the beginning after the install.
What was it after the? Yeah.
Yeah.
I got it backwards. Okay.
So this just fetches all the dependencies and then writes a little shell script which just runs that URL. So it looks a little bit magical, but we're trying very hard to not be magical at all. So this is written this little file catj, and you can run it on any JSON file if you have any.
Oh no, I don't. Oh. Oh yeah, I forgot about that. Here, we'll just. Did that too quick. Oh, come on. There we go.
Anyway, while he's doing that, the point is that we have all these kind of toolings with this. So we have this install command, we have this info command, we have Deno format, and we're hoping we have Deno test, and anyway, we're trying to kind of build a useful tooling around the scripting language so that hopefully. This is just supposed to be a Swiss Army knife of tooling. You can kind of take this little executable and hopefully run programs with it without having anything else installed on your system. So useful for like CI servers or whatnot.
And so I've got a plugin that one of the community members wrote that when you do Deno types, so the runtime type library, which is a bit hard to see there, is sent to the standard in console. A community member wrote a plugin which for VS Code down here, which automatically acquires that for you based on whatever version of Deno you've got running, and makes that part of the development environment. So for example, here we were getting the current directory. And I get all of the code completion that I would expect in there. So because that type library comes with all of the JS doc information that we have in there, and actually if I go to source on that, I can see here where it's automatically acquired that. I can actually go into the runtime type library for Deno, which includes all of that information. So again, all packaged up, every version of Deno comes with exactly the APIs described as types that it supports, which is what your code will be checked against. So one of the things that keeps me up at night is this particular problem, which is hard to read the graph, but on the bottom two bits there, that is our startup time if we're not transpiling TypeScript. Pretty straightforward. The snapshots really come in, make it go really quickly. The top two lines are if we have to take TypeScript in, we've got to spin up that compiler. We only do that if we do it lazy loaded. It's in a worker, a web worker. Again, that sort of following the web standards and the browser standards where possible. And we lazy instantiate that, and we only spin that up if we need to do it. If we need to do it, though, it's about a second, right? So the times are really dramatic, and this is one of the things that, in particular, that I'm trying to figure out. How can we warm up that compiler? And one of the biggest challenges is that the state, the TypeScript compiler is pretty stateless when it starts up. It isn't until you actually go to try to compile something, then it generates all the objects in memory, which is part of the reasons why when we snapshot it, we get all of the code in there, but we don't get any of the state. So that's one of the things that we're really looking into to say, how can we really speed that up and really find out where we're losing the time in there, because that's a pretty dramatic increase or decrease in performance. So what does the future hold? We're going to try to get 1.0 by the end of the year. So I think we're taking a lot of looking at stabilizing a lot of the APIs and at least trying to get to a consistent set of APIs so that people can author Deno and have confidence that it's going to work in the next version. We do breaking changes all the time at the moment. WASM and WASI, so WebAssembly is supported under V8 under Deno, but the ability to import that WASM module into your application isn't there yet, and obviously the emerging sort of WASI to give a lot of access to interfaces for WebAssembly would be important too. Ops, so all of the communication from the JavaScript runtime into the privileged sort of Rust bit. Breaking all that capability out as individual crates is on the roadmap. Having a public compiler API, so if you do want to go back and decide on doing CoffeeScript or Flow, you'd actually be able to load your own compiler in there and leverage the same sort of APIs that we do with the internal TypeScript compiler. Web crypto plus a usable standard library. Web crypto by itself is pretty ugly. And already has a lot of legacy stuff in it. And so one of the strengths that we think that Deno also has is that we're investing heavily in a standard library, right? So that there is a decent amount of code that provides that higher order functionality that is entirely optional, that's only loaded when you require it. More web platform APIs and proper documentation, both obviously the documentation of Deno itself, but also the ability that as you create programs, that you can auto-generate the documentation for those programs and be part of a whole ecosystem. It's an open collaboration. Here are some of the other folks that have been actively contributing to it over the past little bit.
Yeah, and thank you for your time.